Okay, so everybody is good with the table space and what is mean by segment and extent, or anyone having any questions? Okay, so let's move on to the next one. So now we need to learn about what are the mandatory table spaces that we have from 10G onwards. So we have four mandatory table spaces. So starting with the first one, that is system table space. Means the name of the table space is system. So this table space is going to store the base tables, whatever we have talked till now. So in user connectivity and in select statement processing, we talked about base tables. So where all these base tables will store, all these base tables are segregated separately, and they have been allocated a separate table space, that is system table space. And next we have sysocs table space. Now this table space is an extension to the system table space, which means here also base tables will be there, but these base tables are more like they are going to store the data which is useful for report purpose. Like for example, somebody asked you to generate the health check report of the database. So your client requested that. So then obviously you need to extract the information from the base tables. And when you are extracting that report, the base tables will be accessed. Where such kind of base tables will be there, it is in the sysocs table space. Then we have temp table space, which is majorly used for the sorting operations. Like the users, when they issue the select statement, they may give the clauses order by or group by, or sorry, so or any other sorting conditions. So when they are doing such thing, or when th- so when they present such thing, the data should be sorted in some temporary area. So that place we are going to call it as temporary table space. And then we have undo table space. So whenever you know that you execute any DML statement and finally you say rollback, whatever the DML statement that is executed, those changes will be rolled back. Means it is holding the old values somewhere in the memory. So not exactly it is memory, but it is called as undo table space. So let's say you changed the value from 100 to 200 and you said rollback, then you will get your 100 back. So which means Oracle is storing this 100 value somewhere in the place called undo table space. So these are all the table spaces mandatory we have from 10G onwards. Only difference in 9i is in 9i you don't have sysocs table space. Rest the other three table spaces are there. And it is a high level recommendation that we should not create any user related tables in these table spaces. Of course, in temp and undo you cannot create anything, that is by default blocked. So what Oracle recommends is you should not create any user tables like employee table, departments table and all. So you should not create any such tables in system or sysocs table spaces. So you should leave system and sysocs table spaces only for the dictionary information. So that is about the table spaces that we have. So next we need to understand how a DML will process in the database. So let us have a look at that. So in DML processing, the first few steps will be in the same way as the select statement processing itself, because first of all, if you want to do some changes to a value, you need to select that value from the database. So let's say I'm updating an employee name, let's say, or employee salary from 10,000 to 20,000. So which means, first of all, I need to select the value of that 10,000, and then only I can change the value to 20,000. So that's the reason any DML statement will also involve a select statement. So that's the reason initial few steps you will be seeing that it is going to process same as the select statement only. So taking the same, I'm taking an example over here to understand. So let's say there is a update statement issued which is changing the value from 100 to 200 in one particular table, maybe for one particular row the value is getting changed from 100 to 200. Now how this will be done? So user process will issue the statement, we know that, and server process will receive that statement, and it is going to send the statement to library cache where parsing will take place, and optimizer is going to generate many plans and it will choose the best one, and based on that the server process will come down to PGA and it will get executed here, and then server process will start searching for the data in the database buffer cache, especially in the LRU list. So till this point, as I said, it is same as select statement processing. So let's assume server process couldn't able to find any data in the LRU list. Then what it will do? It will come down to database and it is going to pick up the blocks. Now if it is a select statement, it will copy only the block which is having the data. For example, I have a block here which is having the value of that 100, so it will copy that particular block. But this is a DML statement processing. So what server process will do? It will copy this block of 100 and it will copy one empty undo block. So generally this we call it as a data block. The block which is having the data, we call that as data block. So along with the data block, here server process will copy one empty undo block. So once it has copied both these blocks, the data block and undo block, again both of these blocks will be copied to your PGA for further processing. So in PGA what happens? Initially I have the value of 100 and this is my empty undo block. So this value will be transferred to here because as I said, undo is the table space, or undo is the place where it is going to store the old values. So this value of 100 will be pushed into the empty undo block, and whatever the new value that user is asking for, that is 200, will be inserted into the data block. So this action will take place in PGA. So which means here data block also got changed because its value got modified, and even undo block also got modified because earlier undo block doesn't have any data, but as of now it is having some data in it. So because both the blocks got modified, or whenever there is a modification happen to the database data, Oracle is going to record that information in the form of redo entry. We call that as redo entry. Now what is this? So it is just like a logbook. So for example, if you visit some office, some corporate office, they will at the security gate, they will make a note of all your details. And if the security is a little bit higher, they will take the address proof or ID proof of yours, and they will take a photograph of yours, and they will give some visitor pass kind of thing. So that is kind of log that they are maintaining about who is coming into the office and all those things. So similar to that, here also Oracle is going to record this information of what changes has been done in the form of redo entries. And redo entry will have all this information. For example, it will have uh, information like date and time on which this change happened. So on which date and appropriately or approximately at what time this change happened, that will be recorded. And what is the table name in which you have done the modification will be recorded. And what is the table space name in which this table is existing, that will be recorded. Then what is the new value that you have inserted, so that will be recorded. Like for example, 200 is the new value which we inserted, so that will be recorded. Then whether this transaction is committed or not by that time, means that by the time when redo entry is getting generated, whether commit was issued or not, that will be recorded, committed or not committed. Because sometimes if you execute a PLSQL program, you can put a commit immediately after the DML statement. So that's the reason it will record that information. And it will also record some information or some number called SCN, which stands for System Change Number. So we will discuss more about SCN later, but as of now you can remember it will record that SCN information. So like this, some more information it is going to record it. So all this information combined together, we are going to call that as redo entry. Now, always it is like how many changes happen to the database, those many redo entries will be generated. Now here if you look at in PGA, how many changes happen? There are two changes happen. One is for the data block because its value got changed from 100 to 200, and second is undo block because there also earlier undo block is empty, now it is having the value of 100. So which means two redo entries will be generated. Suppose like this, if 1000 blocks got modified or 1000 rows got modified, then there will be 1000 redo entries generated. So always how many changes happens to the database, those many redo entries will be generated. So here once the modification happens, we will be having redo entries generated in PGA. Now these redo entries, whatever that are generated in PGA, those will be copied to a memory component called log buffer cache. So if you look at the architecture, we can see that. So here you can see which is there in the form of circle, redo log buffer. So either we call that as redo log buffer or we call that as log buffer cache. So that whatever the redo entries that are generated in the PGA, so those redo entries will be copied over to this log buffer cache. So whatever the redo entries, so redo entry 1 and redo entry 2 in our case, in our example. After that, whatever the blocks that are modified, these blocks will be copied to write list. So your database buffer cache is divided into two separate components. One is LRU list and the second one is write list. So whatever the blocks that are modified, those blocks will be copied onto this write list. So one with a value of 200 and another with a value of 100. So in Oracle terminologies, these blocks or these modified blocks are called as dirty blocks. So that is name that was given. So modified blocks in Oracle terminology are called as dirty blocks. Now,
So one, whether it's committed or uncommitted, so those data we'll call it as dirty blocks, right?
yeah, it is irrespective of commit or not commit.
Okay.
So now, so we got two actions. One is redo entries were copied to log buffer cache. Number two, the dirty blocks were copied to write list. Now we have a background process called log writer, LGWR. We represent with the name of LGWR. Here you can see that. So what it is doing, if you take a look, it is taking the data from this redo log buffer cache and it is writing them into the online redo log files. So that is what the next step is. So from this log buffer cache, whatever the redo entries that are generated, those redo entries will be taken by this log writer and they will be written into redo log files, or we call as online redo log files, whatever be the name you call it as. So log writer's responsibility is to write those redo entries into the online redo log files. So that is the next step. And after log writer writes, then we have another background process called DB writer. And here you can see what the DB writer is doing. It is taking the data from the buffer cache, especially from the write list, because in the diagram they have not segregated into LRU and write list. So from write list, DB writer is going to take that information and it is going to write them into data files. So what information is there in the write list? Dirty blocks. So DB writer is going to take the dirty blocks and it is going to write them into the data files, which means this data block, which is having the value of 100, now will be replaced with the new value, that is 200. Similarly, the old undo block will be now replaced with the new undo block, which is having the value of 100. So with this, we can say our TML statement has been successfully completed. Now, here the point that you need to understand is nowhere we mention the commit. Now, you may get a question, if commit is not mentioned, why DB writer is writing that information permanently to the database? When you are writing something to the database, it means that you are making the data permanent. And we know that only committed data will be there in the database. If there is any transaction which is not committed, then that data will not be there in the database. We know that already. But here if you look at, Even though the user has not given commit, the data is getting written into the database. Why it is so? It is because uh, the default mechanism of DB writer is to write into the database, and moreover, rollback is a very rare situation, especially if you take a look at the production databases. You will be rollbacking the data only when you identify that you did a mistake. So especially if you are inserting the data from the application, generally you don't have an option to roll back. So while entering the details, or you're submitting, let's say, some user details, so that time itself you need to make sure that everything is correct. So let's say government is submitting the Aadhaar information. So we need to make sure while submitting itself. I'm not sure, but when I went to the Aadhaar center and they filled all my details, before they click on the submit button, they asked me to re-verify everything. So they asked me to check my name, address, everything. His spelling mistakes are there or not, everything. So because once the data is submitted, again if you want to modify, then separate process would be there. So that is the reason there is no rollback concept, or very less cases we will be having rollback concept. So that is the reason always Oracle works in a forward way, that is committing the data. So that is the reason here, even though the data is, even though the user has not given any commit statement, still the data will be written into the data files. Now you may ask me a question, what if user says rollback? After doing all these things, for example, our users finally said rollback. Now what happens? Now for us, rollback is a simple command. But just think logically, what is mean by rollback? Initially, you are updating a value from 100 to 200. That is your original statement. And what is the rollback of this statement? Update 200 to 100, isn't it? So when you say update 100 to 200 and rollback is nothing but a reverse update. Again, it will update the value from 200 to 100. Similarly, let's say you are inserting some 1,000 rows and you said rollback. What happens? We may issue rollback as a single command, but internally what happens? Oracle will delete all the 1,000 rows. Which means if you say rollback, internally one more DML statement will be executed. Initially, insert is executed. When you say rollback, delete will be executed in the background. Similarly, when you say delete and rollback, it will be reverse one. So that is insert. So which means again the processing will take place. When you say rollback, for example, let's say, so new state internally, this update statement will be initiated. Update 200 to 100. From there again things will start. User process will be giving to server process, server processing going to library cache, etc., etc. Whatever we discussed, everything will be done again, once again. And because again you are perform, so this is one change that you perform. Oracle will consider this also as another change. So for this also redo entries will be generated. So I hope you people got the point what I am saying. So more, of course, today itself we cannot understand entire working architecture. So going forward, we will be learning about SMON. So during that time, you will understand very clearly about exact functionality of Oracle architecture. So is that clear? Like how a DML will process in the database? Okay, so now the very important, one of the important questions in interviews, what they ask you is, they will ask you the same question, whether data will be written to data files even if it is not committed or not. So just now I told you, yes, even though the data is not committed or commit point is not yet issued, still the data will be written into the data files. So to confuse you, they will ask you something like, are you sure, and all, but you need to stand strong. Yes, data, uncommitted data, very simple to say, uncommitted data will also be there in the data files, but for temporary time. So that is one question. And the second one is, we have something called write head protocol, which means log writer always will write first, then followed by the DB writer. In no situation, DB writer will write first and then followed by log writer. So that is how the mechanism is designed. So this particular thing, log writer writing before DB writer, we call that as write ahead protocol. So in interviews, they may ask you this question if at all they are going, in depth with the architecture.
Yeah, hi Pawan. Can you explain that diagram once again?
Uh,
Just like someone.
sorry, Satish, I couldn't get your voice clearly.
Okay. The diagram. So you drew the diagram, right? Can you just go through it once again?
Okay,
How
so
can you see? Okay. So
yeah, yeah. You mean to say like repeat once again this DML processing, right? Okay. So taking the things now, let's take a different case this time. Let's say inserting some 1,000 rows. So how an insert statement will work? So user process will issue the statement. Server process will receive the statement. It will send to library cache where parsing will take place and optimizer will generate best plan and all. So by taking that plan, server process will come down to data PGA and it will get executed there. Then it will start searching for the data in the LRU list. So if the data is not available, it will come down to database and it is going to copy the blocks. So now because this is an insert statement, obviously if I want to insert data, I need to get a new empty block. So already if the block is having data, I cannot insert into that. So I need to have either full empty block or half empty block, whatever it is. So whatever the data block I have, so that data block and one undo block. So both these blocks will be copied to LRU list. One empty block and one undo block. So of course, both these blocks again will now be copied into PGA. Now, I hope you people know about this. In database, we'll be having, or in tables, we'll be having null value. Now, when we say null value, for us, null value is something like a non-zero value. I mean, either it is not a zero or it is not a value which we have. But internally, null value is always represented with a garbage value, some hexadecimal number. So, so even though initially this data block doesn't have any data, still it will contain some garbage values. So those garbage values will be pushed from this data block to this undo block. Then the 1000 rows, whatever you are talking about, so let's assume those 1000 rows are inserted here, and your undo block will be having those garbage values, which means here two changes happen. One is data block got modified, second one undo block got modified. So as I said, for each change there will be redo entries generated. So whatever the redo entries that are generated, those redo entries will be copied to a memory component called log buffer cache. And also whatever the blocks that are modified, we call them as dirty blocks. So these blocks will be copied into your write list. So from here there is a background process called log writer. It is going to write down the redo entries to redo log files. And there is another background process, db writer. So this background process is going to copy those data blocks and undo block to the database. Means whatever the original blocks are there, it will replace those blocks with the new ones. So which is having the garbage value. So this is what will happen in the case of insert. Is that clear, Satish?
Yeah, thanks for invite.
No problem. So coming to DDL statement processing, like create table, truncate table, alter table, drop table. So how these kind of DDL statements will process? It will be processed in the same way as DML only, because for us externally it is DDL statement, but internally it is DML statement for the base tables. Now what exactly mean by that? For example, when you are creating new table, let's say create table T1, then when this table is getting created, so many base tables will be updated, or so many base tables will be inserted with a new value. Like we need to insert one new row with respect to this table T1 into obj dollar, then tab dollar, then column dollar, etc. So means one new row will be inserted on the name of this T1. Similarly, when you drop the table, then this row, whatever the row that is already there with respect to T1 in obj dollar, tab dollar, and some other base tables, those should be deleted. So internally Oracle will execute a delete statement. Similar way, you executed some alter statement updating a data type value from varchar to 50 to varchar to 100. So this is a internally, this is a update statement for the base tables. So whatever the DDL statements that you have externally, for all of them we have internally base tables. So that's the reason the processing of DDL statements is exactly same as DML processing. So here the complete picture was given, what exactly it is and all. So whatever we discussed here you can see. For example, we have server process, and to this server process we have PGA attached. Of course, PGA was again divided into several memory components. We will be learning about that later. Then if you look at here from data files, if you look at the select statement processing, so ultimately the data files are being copied by the server process and the data is being stored in buffer cache, and whatever the redo entries that are generated in PGA, I said those will be returned to log buffer cache. So you can see that arrow here. And from log buffer cache, we know that log writer will write. So that arrow was here. And from buffer write list, we have the dirty blocks written by DB writer, so that you can see here. So all these whatever we discussed are represented in this diagram. Of course, we have several other background process and all, which we will be discussing gradually. So whatever the architecture that we have learned, we call this as dedicated server architecture. Now, why? What is the reason? Because for each and every user process, there will be a dedicated server process. So for example, here you can take a look at the picture. So there is a client process. Client process is nothing but user process. So for this user process, you can see there is a dedicated server process, and there is another user process. For that also you have a dedicated server process. So like this, if you have 1,000 users connected, then there will be 1,000 server processes. So for each and every user, there will be a dedicated process. We call this as dedicated server architecture. Later down the line, we will be seeing one more type of architecture, that is shared server architecture, in which what happens, multiple user process combined together will use only one server process. Means instead of one-to-one relationship, we will be having many-to-one relationship. So why we will use that and all, we will understand during that time. So let us try to understand about components of database architecture. Some we know already, but some we don't know that much good. So the first one is server process. We know that it is a process which will do the actual work on behalf of the user process. Next comes the PGA. So when you segregate your PGA, as you can see in this picture, you will be having different areas. So like session memory. So whatever the user that has connected to the database. So for that particular session, details will be collected, like what is the username, from which machine that user has connected, and what program that user is using. So all such information will be collected, and that information will be maintained in this session memory. And then we talked about execution. So execution will take place in this runtime area. And we talked about the modification during DML processing, like undo block and data block will be modified. So that will be happening in this persistent area. Like that, we have some other areas as well. So coming to the points, we know the first point already. Memory area that is allocated to server process is called as PGA, and we know the second one as well. It is used to perform the SQL statement, and it will also store the session information. How we are going to allocate the size to PGA? So with the help of a parameter called PGA underscore aggregate underscore target. And where we will be defining this. So let's say I want to give 2 GB. Then I need to say PGA underscore aggregate underscore target equals to 2 GB. So where I need to give that, I need to put this value in a file called parameter file. Let me show you that. Yeah, so if you take a look at the architecture diagram, here you will see one file by the name parameter file. So whenever I say parameters, so those will be specified over here. So it will be a text file. So with the help of VA editor, we are going to write down there. So later, I mean, when we start with the practicals, you will understand more clearly about that. So we are going to say one line like pj aggregate target equals to 2 GB in that parameter file. So what happens is when you are starting up the database, Oracle will always read this parameter file. And when it is reading that parameter file, it will understand that okay, my DBA wants to allocate 2 GB of memory to PGA. Then it will go to operating system and it will say, boss, I need 2 GB from your memory or from your RAM in order to allocate to my PGA processes. So let's say RAM is 8 GB. So out of 8 GB, operating system will give 2 GB to this PGA. Like that, the things will happen. Now, if you remember a while ago, we said that sorting will take place in a table space called temp table space. Now, that will come into picture only if your data size is more, means the size of the data that you are sorting is more, then temporary table space will be used. But PGA also contains sort area. So here if you take a look, so the first component in this diagram you can see sort area. So PGA also contains sort area because sorting in memory is faster than sorting in the disk. When I say temporary table space, it is a disk. So sorting in disk will take lot of time than sorting in the memory. So if the data size is small, let's say you want 10 MB or 20 MB or 50 MB, so that much data can be sorted in the PGA itself, and that we call it as in-memory sorting. So more about this we will be understanding in performance tuning as well. So because sometimes sortings also will cause slowness. So that time we might need to increase the PGA size as a solution. So we will see that in tuning. But as of now, you can remember if the data size is small, then sorting will take place in the PGA itself. If the data size is large, then it will make use of both PGA as well as temporary table space. But the problem with using temporary table space, as you know, the performance will be degraded because more number of IOs will be involved because temporary table space will be there in on the disk. So more number of IOs will be generated and that will gradually degrade the performance of database. So that is about the PGA that we have. So one more thing here want to tell you is I said that we are going to use this parameter PGA aggregate target to allocate the memory. So as I given an example 2 GB. Now how this 2 GB will be distributed across the users depends on the number of users connecting. This value will be segregated. Like for example, if you got 200 users, so 2 GB is nothing but 2000 MB. So then each user will get 10 MB. Or if the number of users are 500, then 2000 GB, 2000 MB by 500 users. Then each user may get only 4 MB. So like that, if the number of users are more, obviously the size of the PGA allocated to one server process will become less. So that's the reason whenever as a DBA we are allocating the PGA size, we need to keep in mind the maximum possible number of connections to the database. So we need to take that into consideration and accordingly we need to allocate the size. So then comes to Oracle instance. So as we already know, instance is a combination of memory structures and background process. All the memory structures combined together, we are going to call it as SGA. So some people call it as shared global area. Some people call it as system global area. As per the book, the abbreviation is system global area, but shared global area is more way to remember it. Now why? Because all the components inside SGA are shared. Like if you take shared pool, database buffer cache, then we have log buffer cache, etc. etc. All these memory areas are shared across all the users. Whereas PGA is not like that. So that's the reason PGA is called as private global area. So how I can differentiate this one is, suppose if you are attending some classroom training, and let's say the trainer is showing something through a PowerPoint presentation. So everybody in the class will be seeing that PowerPoint presentation, which means that that PPT is shared across everyone. So that is like SGA, which is shared across everyone. Now let's say individually each and every candidate who is attending the training is taking some class notes. So one person class notes may not match with the other person class notes because they will be writing individually, and that we call it as PGA. So your own class notes is like a PGA, and the things that are shared with you is like SGA. So talking about the first component in SGA, that is shared pool, we already know that. So it is having two components again: library cache, where parsing will take place; data dictionary cache, where the copy of base tables will be stored. Individually, you can allocate the size to this shared pool with the help of a parameter, shared underscore pool underscore size. Again, we need to declare this parameter in our parameter file. Then comes to buffer cache or database buffer cache. This also we understood. It is again divided into two components, LRU list and write list, and the size will be defined by a parameter db underscore cache underscore size. Then we have log buffer cache. Just now we understood a while ago that it is going to store the redo entries, and the size will be allocated by a parameter called log buffer. And one important thing is, log buffer cache should be allotted with the smallest size than any other memory component in SGA. So you can give whatever the value to all the other components, but for log buffer cache, you should give the smallest size when compared to the other memory components. So when I say smallest size, don't think of like 25 MB, 10 MB or like that. But let's say if you have allocated some 8 GB to your buffer cache, then you may allocate only 1 GB to your log buffer cache. So that is, the thing. Then we have another memory component which we have not discussed till now, that is large pool. So this is another memory component what we have. So especially this will be used during RMN backup. I mean, we have a methodology to take the backup in Oracle called RMN. So when you are taking that RMN backup, it will make use of this memory component. But it can also dedicate its memory to shared pool. Let's say shared pool is going out of memory. So it's whatever the size, sorry. So whatever the size we have allocated, let's say it is reaching its maximum value, then shared pool can borrow some amount from this large pool. And of course, once the work is done, it will give back. Then the size is defined by large underscore pool underscore size. Similarly, we have Java pool, in which all the Java specific code and all will be executed, or any JVM related components will be executed, and size will be allocated to this Java pool size. So there may be a question, why exclusively we have only Java pool? The reason being is most of the Oracle code is written in Java. So later when we are doing the installation, that time I will show you. So you will be seeing so many jar files will be there in the database. So that's the reason, to execute them, we require an exclusive memory area. And in Oracle 10G, Oracle has introduced a new memory component called stream pool, and this is used for a technology called Oracle Streams. So in case if you want to replicate the data from one database to another database, we can set up that with the help of a utility called Oracle Streams, but it is out of date now. I mean, nobody is using it. So if at all you are using Oracle Streams, then you need to, give some value to this stream pool. But this Oracle Streams is almost, we can say, as a failure model. So even though I mean, during that time, 10G and 11G, some people implemented this, but it doesn't yield very good results. And that's the reason Oracle has replaced this Oracle Streams now with Oracle Golden Gate. So Golden Gate is also a replication utility that we can use. So that is about stream pool. So I will stop it here, and we will continue about SMON and other background process in the next class. So anyone having any questions?
Oh, like tomorrow we have class. Holiday.
No, actually, like tomorrow, as you know, we have a festival. So I am just thought of announcing it. So tomorrow we will not have class, and as you know, weekends also we don't have any class.
Yeah. So you said the data will be, I mean, so when we are updating a table, data will be copied to undo also, right?
The old data.
Okay. So what if undo table space is full?
Okay, so if the undo table says is full, and let's say you are performing a transaction, obviously the user will get error.
Okay.
So there is, I mean, undo table space is what I can say. Its functionality is very difficult to understand. I mean, many people as of now, like they couldn't able to understand about undo table space, but it's very simple actually. Only it is like people will get confused all the time. So when we discussed about undo management, I will make the things very clear for you. But to answer your
Okay.
question, user will definitely get an error stating that space is exhausted in this undo table space.
Okay. Yeah, there is some Aura 1555 error. That's the error you're saying.
Yeah, so Aura 1555 is something a different one. It will not, you will not get because of space issue. We will see that in detail. We have very good example with Aura 1555. So we will see that one.
Okay. Sure, bro.
Yeah, hi Pawan.
So anyone having any more questions?
Yeah, hi Pawan.
Yeah, please.
Is this architecture concepts are completed or not?
No, not yet. We have still more things to go with because whatever we are discussing, still we need to discuss about background process, especially SMON. And once it is done, then we need to go ahead with 11G, like what components are newly introduced in 11G, and then 12C. So probably another 2-3 days I'm expecting. Maybe by Wednesday we'll be done.
Even Saturday also we don't have the class.
No, Saturday and Sunday we don't have class.
Or any every week or only this week?
No, no, every week. Strictly, it is only 5 days a week, Monday to Friday.
Okay, okay, okay. Thank you. Thank you, Bon.
No problem. Okay, guys, then let's meet again on Monday. And I wish everyone a happy Vinayak Chaturthi. Enjoy your festival and have a nice weekend.
To the same. Thank you.
Thank you, Ron. Thank you.